Hi everyone. So today, basically, I'll be showing how we can, kind of go over the source code using Vim. So basically, Vim is my preferred editor. So I'll show a couple of tools that I use, on a day-to-day basis, not just, for developing NumPy, but just developing code in general. And hopefully, you can also incorporate these tools, and it'll be it kind of makes easier to browse code, and that should not be a hindrance to your development, which is kind of the motive of today's session. And later on, we'll basically go over, how to debug crashes in NumPy. And basically, it's a C-level debugging, where I'll basically show how we can analyze code files, and also if there's not any code file, how we can use GDB effectively in order to browse the code on a live manner, print out variables, and how we can actually take it forward. So a bit of introduction about myself. So I am basically a computer science graduate, and I've been working at Citrix and Amazon. And I've been contributing to NumPy for a little less than 2 years, I think. And yeah, so let's get started. So this is what I'll be covering for today. It's a very brief, set of topics, but I would strongly, suggest that just stop me anytime, because this is going to be a very interactive session, and this is just very loose agenda. So yeah, just feel free to stop me anytime if you have any doubts or if you have any suggestions as well. So the day typically starts with just opening a shell. Everything is going to be here. And okay, let me zoom in a bit. Okay, so yeah. Okay, so first of all, just using the raw shell is going to be pretty tedious, because you might have to open a couple of shells. So what I generally do is use a tool called tmux. Now tmux is, I'll quickly show you, what tmux is. But again, when you're going to like boot up your PC, you're going to have like a hard time just opening everything up, right? So that's kind of going to take some time, and it's really a repetitive task. So why not just automate it? So there's a tool called tmuxinator that I use that basically just sets up my virtual environments, like one for testing, one for development. And it basically installs all the relative packages that are needed to get started with development. And I just have a script that asks whether I want to clean my workspace or not. So usually, if I'm going to start fresh, I do a git clean before I start. So now we don't need that. So I'm just going to press no. And this just sets up my entire environment in an automated fashion. So here, this side I have like the source code, and this side I have all the test scripts. So this is, basically just Vim opened up and kept, so that we can directly use it. And these are basically called windows. So this is the editor window. And over here we have like the build window, test window, and just to see if, I'm trying something or not, just have like headstop open. So I'll just see, how much usage is there, and, just, a couple of screens. So today we won't be using much. And one screen is enough for today. So, I'll just quickly close this. And here I have the, okay, so this is the virtual environment that is set up. So this is like the development environment, and this is the test environment. So usually, when we run the PyTest, I prefer having a separate, build altogether. So that basically installs the test requirements. And over here, this also, installs a test, this one. But this is for like a different Python, right? So, okay. Any doubts? So far you can stop me on what these tools are, or how you can use it, or if you have any doubts, let me know anytime. Okay. So today, right? Basically, we'll be going over one of the pull requests that I'm currently working on. So I have it open over here. So this is basically the hex and from hex function of Python. Okay. So basically what this does is gives you a hexadecimal representation of a floating point number, so that it's easier for debugging and those kind of good stuff. where you can just print it, and it's accuracy and those kind of things are basically useful for the hexadecimal representation. And I basically taken Mark's implementation and I ported it to NumPy. So in NumPy, there are a couple of challenges. That is, basically supporting different bit ranges of the variables. So it could be like, typically a Python float is just 64-bit, but we have support from 16 to 128 bits. So that's where the challenge comes in, and it's really useful to use a debugging tool like GDB, which I'll be going shortly. Now, let's kind of open the source code. So I'll show you how, you can use Vim effectively over here. So this is an extension called Nerd3. Okay. Excuse me. So before that, basically, you need to install some of the plugins. I'll basically show the plugins later, if you have time, but a raw Vim is going to be a little, it has all the functionalities, but you can install plugins based on what you like. So mine is quite highly customized over the years. So it might look different than you're just opening Vim for the first time, so just a little heads up. So if you at this point, I don't even know which is a plugin and which is normal, but yeah, if you see something that is not there in your system, you can ping me anytime. I can show you how to set it up for you. You can just ping me on Slack. So basically I'm going to search for the file, right? That is this source file. So here I basically have the implementation of the functions that are needed. And okay, so before I do anything else, let me just open another file. So the Vim buff gets populated, so it makes sense what I'm going to say next. Okay, so now typically, let's say you're using VS Code or IntelliJ or something, you're going to have tabs. Now when you're using Vim, there are either you can use Vim tag or Vim buffers. Okay, so I prefer buffer mainly because my company used to use Vim buff. There is nothing like one greater than the other, but this is just something that I got used to, so I use Vim buff. So so what Vim buff does is it basically opens the files, in a separate buffer, or we can just call it tabs or something like that, right? It opens like this, and we can easily navigate. So you just you do colon B and then the number. So if you do 3, it goes to the third buffer, and if it goes, you need the fourth, it goes to the fourth. So typically when you're developing a scalar mat function, these are the only 2 files that are very important. So one is going to have, is going to receive the Python object, and later you do some sort of mat stuff on it that will be in the mat internal, heads.source. So let's say, you want to have these 2 side by side, right? Like it's not exactly going to be convenient to just keep switching buffers every time. So there's something called vertical split that you can do. So you just do like, vert SB and 4, right? And it just opens up in a separate tab, okay, in a separate, window type in the side. So this is something that is really useful to, just have 2 things side by side, so you can, just look, right? Like one function is going to call the other, so you can just have both open, right? So this is kind of, it's kind of useful, I feel. Okay, so let me close this. And okay, so far I hope Vim is clear in terms of like how all this stuff is going on. So please let me know if you have any doubts on like what I've done so far, if anything doesn't make sense, or stuff like that. So what I'm going to show now is ctags and cscope. Okay, so far, okay, what we have done, we have opened a file, we have opened multiple files, we have had them side by side, but still we need to like go to the definitions, right? So let's say we have something like okay, let's go here maybe. Yeah, so okay, so this is one interesting function, right? Like by array scalar value. So let's say you want to quickly find out what this function does. In excuse me. So in VS Code or something, you just hover over it and it's going to take you to the definition. So how do you do that in Vim, right? So that's where ctags and cscope is a useful tool that comes in. So first I'll be showing you ctags. So for ctags, you first need to generate a tags file. Okay. So you generate this tags file by doing ctags -r dot. So this basically, generates the tag file called tags. And, if you just see the file, it's just going to be some bunch of stuff, you don't need to worry about it. But Vim has integration with ctags to use this information to browse your code. Okay, so what happens is you move your cursor, near that variable, just place it anywhere, and you press control and square brackets, right? The right square, the right square bracket. So when you click on it, it opens the definition in a new tab. So over here, if you see, it's opened it in a random, some buffer 6, where we have this here. Let me just remove the, yeah, okay. So here we have, the definition pi array scalar val. So basically, you can see that what this does is it takes the object that, we're dealing with and some sort of, some string called CLS, and it's going to append it. And it's basically casting it and taking the OB val, right? So, I mean, not very important to our conversation, but basically you can see that, we are able to quickly go to the definition to see what it does. So let's say you're copying code from some other function and you want to see, what it does. This is, how you do it. But, ctags has a problem, right? I've gone to pi array scalar val, but let's say I want to go to this scalar object. I want to see what the scalar object does. But there is a CLS over here in between. So if I go here and if I just do that thing again, it's going to say tag not found, because it's not smart enough to figure out like where, like what we're dealing with over here, right? So this is where cscope is very helpful. So over here, we can ask cscope to find a definition of a particular thing. So if I press Control T, it takes you back. And over here, you see, we're doing like at name, right? So name is basically over here, if you see, it's like double or something like that. So going back, just a second. Yeah. Let's say, we want to search for that, right? So what we do is we use CS and we do find. And, after that, there is a couple of things that you can do. So if you press tab, it's going to say like ACDE, I'll show you what these actually mean. But for our case, we want to find the definition of this particular object, right? So we go over here and it's going to take you to the exact, to the exact definition of the object. So all you need to do is CS, something like that. So let's see, what those things exactly are. So if you just do help, right, it's going to open up a different tab and it's going to show you the different options that are available. So here you can see that what we did was G, right? So G is basically find the definition of a given variable. So the other things, we're not going to exactly use for today's session, but these are very useful. And you can see that, it's quite powerful because some of the modern, IDEs won't have the particular, functionality, like finding functions that are called by this function and so on. So when you start getting deep into developing in C, C++, and, those kind of things, these are like really useful tools, I feel. And cscope is going to help you there. So yeah, okay, so this is a bit of the boring stuff, I would say, but hopefully it was helpful on just looking at how I use Vim. So this is a good time to ask any questions. If you want to know how to do something, or if anything's unclear, please let me know now.
I got a question.
Yeah, it's done.
I think I did the hand reaction. I'm curious. So when did you feel ready to have like the different environments or your custom setup? Because I see you have a lot of useful things like tmux for automation, but in for my own experience, I don't have a lot going on, and like I use VS Code, and what thing I only really work on the NumPy website. So I feel like branches are like my informal way of creating an environment. And I know that like environment, like packaging and things like that is an art form, but I do feel a little like overwhelmed at the thought of like having like this whole setup. I mean, that's how I feel. So when did you feel like ready to have all this set up ready?
Okay, yeah, that's a very good question, and thank you for actually telling that, because the whole aim of this is not to scare you away from Vim and Tmux, because it looks a bit overwhelming at first. But what you need to understand is what I've set up here is not just for NumPy, but rather my entire development environment that I've been developing since my first year of college. So that's almost 8 years worth of putting stuff into it, and I just maintain a gist, a GitHub gist that has all my configuration files and all my tools that I'm going to use and how to set it up. So what you're actually seeing here is 8 years worth of me like adding stuff to it. So probably in my first year of college, and I was like kind of forced to use Vim because there's no other editor available in the PC. I started using Vim, and I used to just know how to go into insert mode, right? I used to just know how to like write stuff out and quit, because if you press Ctrl+C, right, it tells a very funny thing. So you might have seen a lot of memes where they say, quitting Vim is like really hard, right? So it's a very slow process. And what happens is when you start doing something repeatedly, you kind of want to automate it to so that like it I mean, at least I would kind of be lazy to do it again and again, so I kind of write a script to do it. So which is kind of what happened. If you see the starting script, right? So if you see the starting script, it basically so okay, first of all, thanks to Ross for introducing me to this work on, and as this virtual environment that was like really useful. But so basically yeah, like I said, right, like Ross showed me how to use the virtual env wrapper. So it's more like exploring and finding stuff that are better than what I was currently doing. So to give you a brief overview of something like why I have like 2 tabs for dev and test, right? So when you build test, it kind of creates an environment, and again, if you want to get into a shell and use it, I wasn't able to do it, so I kind of split it. So that's where you kind of get like 2 tabs. So what you're seeing here is basically like slowly adding stuff to your given environment. It's more like how you're using VS Code, you might have added some extensions, right? So you would have added an extension because you found something missing in your current environment, which is kind of what happens over here also. It's kind of very similar, like how you add VS Code plugins. Here you can add Vim plugins and so on. So yeah, so what you're seeing here is basically like a lot of many years of experimenting and trying things out. So hopefully no one's overwhelmed by what I've just showed, but rather this is to an extent the stuff that you can do with Vim is kind of what the aim of the session is.
Yeah, so it grows organically. That makes sense. I guess for me is a parallel is that I have like automation, like I have like a whole system for like project management, or like my planner for my life. So I have a whole like setup, and I have different like systems that I try to fit in within each other. So I could see, I guess, over time as I get more familiar with this type of work, that I would want to like or grow organically to have all these like efficient things and systems. Thank you.
Yeah, welcome. Okay, so let me just quickly see the sorry, I don't miss anything. Okay, scope hex. Okay, so let's look at the excuse me, sorry, let's look at the core file, right? Okay, so what I've done here is so basically I've introduced a bug purposefully. So it's kind of a session where if anyone can find a bug, you can just you can put it in the chat, or you can just interrupt me anytime. But this bug is basically something I found out during my development of the function. So I thought it's a good thing for people to show. It's a very simple bug to fix. Also, core files are pretty rare. Usually the bugs will be something like something not working as expected. In my company, I would say, when I used to work at Citrix, core file is kind of the best thing that can happen, in a customer issue, because when you get a core file, you know exactly where it's going wrong, and it's not like it's going to be easy to reproduce the issue. So whenever there is a bug, right? You can use this for anything for that matter. When you're dealing with a bug, the first step is to reproduce the issue in your own system in a reliable way. Okay, so what I mean by reproduce the issue in a reliable way is you need to be able to hit the code or hit the point where you can constantly try stuff out and see whether you have fixed it. So a core file is really good in that aspect, because what a core file is basically just a backtrace. It's like a dump of the process that was running when the crash happened. So it's very easy to go to the function where the crash happened and reproduce the issue. So first I'll show you how to debug a core file, and then you can see GDB breakpoints if time permits, and how we can debug it. So what I have here is I have built NumPy using this command. So I have aliases for this, but I won't be using any alias for this session, so that I'm clear on what I'm typing. This is how I built NumPy. So this is just to set the optimization to 0. So this is a good thing to have when you're developing NumPy, because you don't want your variables to show optimized out. Okay, so what happens is GCC is really smart. And if it sees that a variable is, you can kind of statically determine its value, it's going to optimize it out. So, but when you're debugging, you need all the values. So it's good to have this. And this is just debug symbol. So I don't know if this really helps. Someone like Sebastian or Matty can probably chime in whether this actually helps in the C Python part, but I just do it for good measure. And yeah, so this is already built. Yeah, so it'll just kind of end quickly. So like I said, you need to reproduce the issue, right? So I have a thing ready called just called hex crash. Okay, so what it's going to do is it's just going to create a float of np.py, just 3.142857 whatever, and it's going to call the hex of it. Okay, so let's quickly see what excuse me, what it's supposed to look like, right? Like sorry, so let's use the the Python's inbuilt hex function that Mark has written. And sorry, right, my bad. Okay, basically it's going to give you some hex value, right? It's going to give like 0x12 something like this. But when I'm going to do something like this, I'm going to get some sort of crash. Okay, it's going to say stack smashing detected. So this is not a typical segmentation fault or anything, but rather something wrong has happened, right? Something wrong has happened, and your shell is also gone, right? And even if you try to execute the script, it's just going to like fail. It's basically crashing. So how do you debug this? So how do you get to the bottom? Let's say you encounter this in some real-time scenario. The first thing is you need to find out where your core files are going to be generated. It's going to be different for different machines, and the file that is going to tell where your core file is going to get generated is called is there in proc system kernel core pattern. Okay, so if I cat this, I have a custom pattern, but you can specify anything that you like, but typically your system will have like a pretty useful description of the core file, and this is going to be mine, right? So if I ls this file, ls this folder here, but it's empty, right? There was supposed to be core files here, right? But there are no core files. There is nothing that is being generated. Why is that, right? It's telling us crashing, but there are no core files generated. So the reason for this is something called ulimit, and this is going to tell the size of your core file. So if you set it to 0, it's not going to like form any core files. So this is the first step that it's just remember to do this, where you set it to unlimited so that it forms the core file. Okay, so this is like the frustrating part where first time when you're doing it, you might see that crash is happening, but you don't have any core files. So now that we set it to unlimited, it's going to form core files now. So I'll reproduce the crash again, and this time you can see it as an additional message printed that the core has been dumped, right? That means we have a core file this time. And if I do ls, I have a core file. So this is great. We have a core file to begin with, and now we're going to see how we are going to debug this core file. So GDB is the tool that we're going to use, GNA debugger, where the first argument is the executable. So if it's a C program, it's going to be your a.out or whatever program that you compiled it, and hopefully it's going to have debug symbols. So debug symbols is going to help you actually analyze the core files. So what we're going to do here is we're going to use the executable Python Tera 10 debug version, and we're going to give the core file as the second input, right? Excuse me. So when you do this, it's going to load all the symbol table and all the good stuff that is needed. And okay, one second. It just said oh, okay, my bad. Okay, it's saying no such file directory. I need to give the full path. I gave the wrong this one, my bad. Let me just give the full path. Okay, so everything has been loaded now. Okay, so now the first thing you need to do is to get the backtrace. Okay, so when you do bt, it's going to give you all the functions that were called from the like basically this is the call stack. So if you look at a typical program, right, in C, it's going to have like a bunch of like memory layout. I won't be going too deep into it, but you might have seen some recursive function for factorial, right? So basically it's going to like have a call stack. So like factorial of 5 is going to call factorial of 4, 3, 2, 1, 1, you hit the base condition and then you come back. So this is like a very simple way that we kind of begin to understand what a call stack is. This is exactly what is happening here. From the main, you're going to have like a bunch of function calls, and finally we have hit like some sort of abort that is going to raise the core file. Now sorry, when you see this, it's little overwhelming where you don't know where to start. You just have some sort of crash and you have some sort of memory dump and you don't know where to start. So what we're dealing with is a NumPy program. So there should be the word NumPy somewhere over here inside, right? So that is what we're going to do. We're just going to search for NumPy. Okay, I'm not going to search like this. It's fine. So you can see that we're going to have this over here. We have the file NumPy, and it's in the double hex function. Okay, so this is a good place to start. So this is these are frame numbers, and this is the frame that we're going to be interested in. So we're going to go to okay. So we're going to go to the 5th frame. Okay, frame 5. We're pressing F5. We go to the 5th frame, and when you press an L, it's going to show some lines above and below. Okay, so we are in this line, and we can see that some function has been called before this that has caused some sort of crash. Okay, so this is the information we have now. So what more information do we need? We need some more information about the variables that are in this stack, because that's going to be our clue, right? So basically we are just kind of doing some detective work here, where we're trying to find out who's the culprit, who is that variable that's causing this crash. So what we're going to do is we can do something like info locals. Sorry. Locals. Yeah, I think there's some beep or something. Right? If someone has a doubt, you can unmute yourself.
Yeah, I have a question is,
Yes, tell me.
before you go into like the variables, how did you know which frame to go into? Was it based off like the call stack?
Okay. Let me show that again. So I'll do backtrace, and here we have like a bunch of functions, right? So the question is, how did I go into frame 5? Like what is special about frame 5? Why not I go into frame 11? The thing is, since we know that we are dealing with some sort of NumPy source code, in this entire frame, we can see that NumPy source code is over here. This is the first call, or rather, coming from the top of stack. This is the first, this is the place where the NumPy code resides. So this is the place where we have written some code, and everything after this is some sort of, Linux code as GCC introducing something, or it's basically not our code. It's basically something else is handling some mistake that we have made. So we know that the mistake has happened somewhere in the NumPy code, somewhere that, we are involved. So the topmost part of stack where NumPy is involved is frame 5. So I'll go into frame 5. I hope that makes sense.
Yeah, I guess it's like starting at the waterfall.
Yeah, exactly. Like
There.
try to, be on the topmost part where the mistake could have happened.
Okay, thank you.
Yeah. And, we kind of do info locals, and we see like there are two variables, right? The value and the buff. So now is a good time to go into the source code to kind of see, like what we have done. If you're doing a live debugging, you can step over the code, which I'll show, if time permits. But right now we can't do a live debug because this is a core file. This is static. You can't, proceed further from this because it's not a live process. So we know that, this is the file, scalar c.source. We have that open, and we have the hex function. Okay. So over here, in this particular line, something is going wrong, right? Some sort of crash is happening in this line. So what we can see over here is, before I started this, you might remember that, in the Python, Python 3.10 does not have history. Okay. So we are going to do float of np.py.hex. Okay. So this is the value that we are expecting. But if you see in a call stack, this buffer, it's basically containing some sort of truncated version of this, right? So if you see, this is what we have. And the length of this variable is 10, whereas the length that we're expecting is 20. Okay, so this is where something is going wrong. So we know that this buff is a character buffer, and there is something wrong in this character buffer. That's something that is being truncated here. So sorry, why is it getting truncated? So we need to look at the memory, or look at the contents of this buffer a little more closely. We want to see what is beyond this buffer. Like, why is it stopping there? What comes after 5? Something is happening after 5, right? So for that, what we can do is x. Okay. 32 BC. Okay, I'll explain what this does, but just bear with me for a while. But I'm just printing this buffer variable beyond that 5. Beyond this, I'm basically instructing GCC that, okay, you think this is what buff is, you think it's 10 bits, but how do you go beyond that, right? How do you want to like print beyond that? So what is happening here is we can see 0, x, 1, 1, dot, everything is matching, and we have 5. And what is interesting is we have everything after that as well, right? We have 8, we have p, we have 1, we have plus. We basically have the entire string. We have the entire string, but somehow we are losing the data. When you're printing this, it's only printing 5. It's only printing till 5, but we have the data beyond that. We have the 20 characters that are beyond that. So why is that, right? So what we're going to do is we're going to print the size of buff, we can see it's 10, right? So it's basically stopping after, um, 10 characters. So basically what has happened here is we have allocated less space in a stack variable, and we're trying to access it beyond that space. Okay, so that is called something called buffer overflow. So you might have heard of buffer overflow attacks and those kind of things. So what we have done here is actually buffer overflow. We have gone over that particular variable's allocated space, and we're trying to access it, and that access might cause something wrong. So because of that, GCC is protecting us and telling there's a stack smash error. Okay, so I know it's a lot to take in, suddenly, but what you need to understand here is we have allocated less space, and we're trying to use the variable beyond that space. So that is kind of what this bug actually is. So please feel free to stop me anytime here, because this is like kind of the root cause. So we call it RCA, right? The root cause analysis of this issue. So yeah, any doubts? Or okay. So what we're going to do is actually we're going to fix this. So we need to increase the size of this buffer. So here we can see, we're given space for minus, plus, the mantissa, the decimal point, the character P, and plus, and or even space for the null character. But why is it going wrong, right? So if you actually open this, you can see that over here, we're going to do size of and into character bit. So I missed a character bit. I missed multiplying by 8. Okay, so I've actually forgot to multiply the given size by 8. So that's a lot of characters that we're missing, right? So we're going to kind of add this back, and we'll compile it, and we'll see whether the crash goes back. So now you might wonder what this char bit is. So this is, you can use ctags for this. And okay, so ctags won't work here because this is a C definition. It's not a NumPy definition. So ctags and cscope will only take you to code from that directory, from NumPy where it is. So let's say this is defined in some header file called limits.h or something, you won't be able to find it. So our best bet is to just Google this, which is kind of what we'll do. We'll search for char bit, and we can see that it's the size of character in a machine. So typically it's like 8, but just for backward compatibility, it could be 7 as well. So we kind of add this over here, and we'll quit, and we'll build the code again. It shouldn't take long. And now when we run the code, it's not crashing, right? And if we kind of go over here, like this can. We're kind of getting the full value. We're getting the full 20 characters that we are finding. Now this is all well and good. A core file is generated, so we are able to like look at the code and things like that. But let's say there is no core file, and let's say there is some logical bug where instead of 442 or something, it's like 5, and there's some sort of discrepancy. How you want to like step into the code live, right? So what we're going to do here is something called live debugging. So right now there's no way to hit that code, right? So what we're going to do, there are many ways to do this. This is something that I prefer. Might not be the best, but this is something that works. So what you can do is you can give GDB, and you can give the argument as the executable. So we're going to give Python 3.10 here. And when you go here, and if you do run, it's going to give you a shell. Okay, it's going to give you a shell. And here, you can go ahead and, you can import NumPy and so on. But what you can also do is you can set breakpoints. So what I'm going to do is, we know the function is double hex, right? We know that the function for float 32 is double hex. So we're going to set a breakpoint here. And it's telling me exactly, where this particular thing is. And let's run again. Okay, let's run it again. And yeah, go ahead, Mas.
So right now you're like investigating if it's a logic type of error. Is that different from the previous type of error?
Exactly. So what we are kind of going to do now is we want to like step over the code in a live fashion to find out if there is a logical bug, or if you just want to see, print out the variables and see the logic of the thing. Because if there's a crash, you have a core file and things, but if there's no crash, how you want to step into a C code. So I'm going to kind of show that.
But then how do you know when to switch that context?
Can you come again? Like, what do you mean by context?
Like how do you know to like, because you were investigating the buffer, but how do you know when to switch to the logic and running the code that way? Because they're different tasks. So when did you know when to do that?
Okay, so if I'm getting a question correctly, I think the question is when do you use this type of debugging procedure, and when do you use the core file, and is that the question?
Yes, I don't fully know what these different contexts are, but I know it's different. So I was wondering like
Okay.
why you decided to change.
Okay, got it. So what happens now is if I go a bit top, if I do, the Python 3.10 hex crash.py, it's not crashing. Okay, but let's say hypothetically, instead of 1.921, we're getting 1.321, or we're getting some sort of wrong answer, and we want to like kind of go back to that situation where we can have GDB open and we can print out the variables. We can print out, this val, and what the self has, and what is the size of this buffer, or what is the contents of this buffer, or we want to step into a given function. So if we want to do some sort of live debugging where we don't have, any crash, or where we can't catch anything, that's where we're going to use this type of, debugging, right?
So if I were to, I don't know if the waterfall metaphor still works here, but would that be like going further back from the start of the waterfall, or like seeing how the water flows?
This is more like seeing how the water flows. There is no waterfall in this case, and you're kind of it's like when there is a waterfall, that you can go to the top of the waterfall. But here there is no waterfall; it's just a river, and you just want to see how the river is flowing. If
Okay,
that analogy kind of makes sense.
yeah,
So you
then
just
that,
want to see what rocks are in which place, or next time when you go, you don't hit it,
that
and
makes
something like that.
thank you.
Okay. Okay, I don't want to type it again. I'll just copy this. So this time we've set a breakpoint, and when we okay, let me input it again. And this time I'm hitting a breakpoint, and this time if you see the backtrace, there is nothing before this. This is the top of the stack, so I'm exactly hitting this. And if you see, I'm kind of near that function, and we can step over the code. We can go next, and we can print out val, and if you print out buff, right, it's going to be empty, or it's just some junk character. It's like GCC doesn't initialize it with some zeros, so this is just some junk value that you don't need to interpret. But so basically you can just step over the code. So over here right, you can start seeing like now if you print buff, it's going to like have the right characters and so on. So this is like really useful, right? So let's say you want to see how this buffer is getting populated, right? So we can just do it again, and the buffer is getting populated in this function, so we can step into this. So if you press S, you step into the function. So over here we see that we're passing the argument, right? That's the actual pi, and we can keep going next, and there is some sort of logic that is happening here, and that is like populating your variable. That's the buffer variable. So this is basically live. We can print out all the stack variables. where we have like a bunch of things. So there could be something logically wrong in this variable I, or the si or the e sign could be like wrong. So you can figure out instead of pressing like print and printf, like let's say you want to find out in a different way, right? You printf si or you printf m, and you don't need to keep guessing. You can step into the code and you can kind of do it. And yeah, that is kind of pretty much it. I think I did cover everything I want to cover. Okay, PBT is quite useful in a way, because this is in the C level you're going to see, but PyBT gives a little more context on the Python. It's little out of scope for today, so let's not look at it. But basically it will give you, like, in the Python code, it'll kind of tell you where you are. It has a bunch of other tools associated with GDB, but you can just take a note of it in the future if you're going to touch this. So any questions? Please feel free to ask. I hope this was useful. I think, yeah, most people usually don't touch the C part, but yeah, I really do hope more people will get into this. And yeah,
this is awesome. Thanks, Ganesh.
Thanks.
I really enjoyed this. I mean, I didn't understand the details, but it was a very useful, like, high-level overview of what the under the hood process is like. And yeah, the waterfall metaphors definitely helped me get an idea of like what's going on.
Okay. Thanks.
Yeah, I just to circle back to Mars's question, like when you use interactive debugging, I've actually used it in the past, not for debugging. Like nothing is actually wrong, but there's just, I'm looking at C code and the logic is really complicated, right? There's like a bunch of ifs and cases and loops, and you don't know how a certain state is being arrived at. And sometimes it can be really hard, especially with C, where things can be, files can be very, very long, and you have to like hop to the bottom of the file or the top of the file just to like sort of figure out, what the next step is. That can be really hard to disentangle. But when you run it interactively in the debugger, then you can step through step by step, and you get, at each instance, as you step one line, you can print out whatever the state of everything is right there. And it's sort of, I mean, this is how I like to do Python too, how I debug Python. I usually have like, or not debug, but like introspect, I guess is a better word. You have like a Python function on the left side, and I'll run it line by line in an interpreter, right? Just have an IPython terminal open and sort of run each line individually, and then I can look at what the state of everything is. And that's sort of what the GDB, running GDB interactively allows you to do with C code. So I've used it in that way, definitely.
Okay.
Yeah, thanks, Russ.
Yeah, because my experience with debugging is more for web development with my own code. So I have like already a sense of what might be going wrong. But I guess that's the challenge with like going under the hood with C code and NumPy, is that it's many other people's code over several lines.
Yeah, like Ross mentioned, right? Like if you just look at the like the NumPy repository, and if you like just open a PR like this, it could look a bit overwhelming, right? Like there's a lot of stuff going on. So if you just want to understand it, you just load this and just set a breakpoint to any of the function, and you can just look at the description, right? You can just look at the description and you can see this is what it's doing. So just hit a breakpoint on any of the function and just call this. And you're going to go into this mode over here, and you can just step over and you can live see the logic, how the variables are changing, and it'll give a better understanding of what is going on. So yeah.
Ganesh, thank you so much. This is super helpful, and I'm so glad that we could record this